There are basically two reasons that could be the cause of f41 error on a solar inverter. The f41 error is the parallel system stop, which usually causes an inverter supply system or the inverter systems themselves to actually shut down. I've seen a lot of forums online that are trying to find out why this parallel system stop occurs on solar inverters, which is the f41 error. So it depends on the kind of inverter you're using. So some other inverters can actually give you a different code number. But for this brand of inverter, the code number is f41. For the other inverters, these techniques I'm going to explain in this video could also apply, but it's for you to understand the reason. There are basically two reasons that leads to a parallel system shutdown for solar inverters. Hi there, and welcome to Catchment of Resources. In this video, we are going to look at how you can actually solve the parallel system stop that are caused on this brand of inverters or probably solar inverters in general. When you are installing your solar inverters to supply your load, there are ways you can actually install it that could lead to a problem in the long run. For example, if you are installing a system for solar and you want it to, let's say you are just installing a single inverter, you are less likely to have the parallel system stop because you are not connecting multiple inverters together. But let's say for example, you are installing a minimum of 2 inverters. As you can see in this schematic, this single line diagram, you are installing multiple inverters together in parallel, as you can also see in the videos. Errors could occur from those. For example, in this video, you have a 3-phase inverter. Errors could occur in this line that is coming out of the inverter. For example, if you do not do your connection well for the parallel connection, let's say you are not connecting all the, let's say, blue phase together, all the red phase together, all the yellow phase together in a parallel connection, you are going to have problem. For example, if you are doing looping on this kind of inverter, you are most likely going to have a problem. So the solution we did was to introduce a bus bar. And with that bus bar, you actually have a way of installing all of the individual cables that are output from the inverter. So the 3-phase inverter, you have blue phase, red phase, yellow phase, and neutral. In this video, the neutral is black. So once you have gotten each of these cables coming out of the inverter, we run them to the bus bar. In that case, you are able to establish your parallel connection. One way to actually find out if your parallel connection is properly done, for example, if you start up your inverter, each inverter is supposed to be showing you approximately equal amount of load that it is supplying. For example, let's say the load is 10 kilowatts and you have 10 inverters. Each of those 10 inverters is supposed to be giving you 1 kilowatt because it's a parallel connection. But because of distance and heat and other factors, it's possible that some inverters could be showing 0.9 kilowatt, some inverters could be showing 1.2 kilowatt, some inverters could be showing 0.8, some inverters could be showing 1.1 kilowatt. But when an inverter is showing 0.1 kilowatt, when others are showing around 1 kilowatt, 1.2 kilowatt, you can then know that there's something wrong with your parallel system. These things I'm telling you in this video is based on several weeks of troubleshooting when we encounter different problems working on this solar power system. So you see, there are multiple levels of error that could occur. First of all, it depends on how you do your connection according to the single line diagram. So if you route all these your cables to a bus bar, it simplifies it for you, so you are less likely to have an error. Another area where we discovered that our system shuts down. For example, this circuit breaker, as you can see here, the circuit breaker which takes output from the load. If one cable, let's say from this 3-phase, let's say you have blue phase, yellow phase, and red phase. If one cable pulls out of these circuit breakers, meaning that only 2 phases are supplying from that inverter, it means that a parallel system stop is going to occur. You just need to wait for about 2 minutes 30 seconds. A parallel system stop is going to occur. So I've mentioned two things now that could lead to a parallel system shutdown on the side of your inverter system. First of all, if you don't do a proper connection to establish the parallel connection between your multiple inverters by running each of the cables from, let's say, phase 1, phase 2, phase 3, and the neutral to a bus bar, connecting each of those ones to the bus bar, then taking just one thicker cable from each of those lines on the bus bar to supply your load. If that is not properly done, you can actually have a parallel system stop, which is the f41 error. Another reason that could lead to this is when you connect, let's say one of the cables for the phases is amiss. So let's say it disconnects from the circuit breaker. So it means that out of the 3 phases, only 2 phases are running. After 2 minutes 30 seconds, you are going to have a parallel system shutdown, because the inverters have sensed that there is a backfeed of current, meaning that one of those inverters is not supplying current to the load as expected. So there might be a return of current. So it has sensed it, which is why it is letting you know that there is actually an error in the output from the inverter. So one way to actually troubleshoot this or to find this out is you can actually tap on the screen. You can actually see load. If you tap on the screen, you will see the amount of load coming out on phase 1, phase 2, phase 3. If one of the phases is showing 0, meaning that that phase has disconnected from the system and it is not supplying the load. Those are some ways through which you can actually troubleshoot your system to ensure that a parallel system shutdown does not occur. Those are just 2 examples of inverter side errors that can lead to a parallel system shutdown. So it's best for you to follow the standard way to develop the network between the inverters for them to communicate properly in terms of the electrical aspect of these inverters. If it is properly done, they are not going to have a parallel system shutdown. So first of all, you have to check your own side of the equipment before you now check the load you are supplying to that is causing an error. So those are 2 reasons on the side of the inverter that can actually lead to a parallel system stop. These are things that we experienced. We troubleshooted for several weeks. We discovered this could be the reasons for parallel system shutdown. And when we corrected it, we stopped having this parallel system shutdown. There are multiple levels of troubleshooting we did while working on this system. There was a time when anytime we power up the system to supply to the load, after about 2 minutes 30 seconds, the system shuts down. We kept on doing it over and over again. The system will reboot itself, then it runs, supplies the load, then it shuts down again. At some point, one of the phases shut down. Let's say the blue phase on our supply to the load at the automatic transfer switch. We discovered that the blue phase was going off. So we now decided to test something else. We now tested 2 phases. So we used just the red phase and the yellow phase, and we ran the inverters again. We ran these inverters for over 1 hour. We now discovered that there is something wrong on the blue phase of the load we are supplying. That's the housing and facility where we are supplying the load. We discovered that there's something wrong with the blue phase of their system. So we now ran just those 2 phases for a long time, and we discovered that these inverters were no longer shutting down. So we now discovered that probably there is a short circuit along the blue phase of the line that we are supplying to the load. So we now kept on doing some tests. We went to the panel in the facility. We checked the current going in. We checked the current coming out. We realized that probably there are multiple connections that have been bypassed from our automatic transfer switch, which could be a challenge. So we look for multiple ways to actually troubleshoot and identify this problem. So after a while, after several days, we now went ahead to see how we can power each of. We first of all isolated all the different units in the facility. Then we started to turn on areas based on the importance or priority of those segments of the facility. So for example, we first of all go for the main house of the facility, then we power it up. We power up the main house for, let's say, 15 minutes. After that 15 minutes, we have confirmed that the inverters are not going to shut down. We now concluded that that main house in the facility does not have any fault. So over time, we now turned on some other equipment. We also realized that at that 2 minutes 30 seconds is usually the period when the compressor of AC units usually power up. So we concluded that this compressor of some AC units may be faulty because not all the AC units we were using were actually inverter AC. Over time, anyway, at the end of all the troubleshooting, we realized that whether your AC units are inverter type or not, the solar system is going to carry. So we assumed initially that it was because they were not inverter type, that probably the compressors were causing a short circuit on the network. So over time, we now discovered several AC units in the facility that anytime we power up these AC units, anytime these AC units compress or power up, the inverter automatically shuts down. So we now identified the circuit breakers for each of those AC units and the water heater, and we shut them down. So we now powered up. We now realized that we were able to run the solar system for about 1 hour. So we now said, okay, we've identified these equipments, that something is wrong with them. During those periods when we were doing the isolation of units in the facility and identification of areas that were faulty, we were able to discover that there is a distribution board in one building that is connected to all those other buildings where we identified the AC units were faulty. So at some point, we were feeling that there are several things that matter in this case. So it's possible that either the connection from that small building to the other buildings is the fault, or this other AC unit compressor are the fault. So over time, we now decided to carry out some level of rewiring of that building that supplies the other areas where we are discovering the fault. So while doing that, we replaced circuit breakers, because the circuit breakers that were there were actually faulty. You can see an image of it on your screen. We replaced circuit breaker, we replaced the main switch and some other breakers. When we did that, we now did a proper connection, because initially most of the cables that were connected to that distribution board were just looped. So they were not really using the functionality of circuit breaker. So if a current that came into the line that was too high, the circuit breaker is not going to trip off, because they are not actually using the functionality of the circuit breaker. They just put a cable in one side of the circuit breaker and they looped it that way. So those circuit breakers were not actually performing their function. So what we did was to replace those damaged and old circuit breakers with new ones. So each of the lines connected to that building had its own separate circuit breaker, taking in current and supplying to the load in that distribution board. We corrected that. We also discovered that there was some poor connection in the ceiling of that building. So we also corrected that. At the back of the building as well, you will see an image on your screen. We realized that there was one significant connection that was done outside the building. If you look closely at this image on your screen, you can see that you have yellow, blue, brown, and black. You see that that's the cable coming from up to down, that black cable coming down. You see that the blue and the yellow have been connected together. So my suspicion was that two phases have been connected together from this cable to supply all the other buildings where we are discovering faults. So when we brought out a new junction box to reconnect this particular cable wiring, and because the cables that were going to the other buildings were only about two-phase and neutral, we now isolated one of these phases. Let's say we isolated the yellow phase and used only the blue phase and the brown phase and the black to supply the other buildings. So you will see in the other image how we isolated it. In the video, you'll see how we isolated that last cable, meaning that one of those phases, two phases were actually tied together, which may be one of the causes of the error we were experiencing. So when we corrected all this cabling, all these shorts, the cabling on the distribution board, the cabling in the ceiling of that building, the cabling on this cable that supplied the other buildings, when we also isolated one phase from this three-phase cable, then we powered up the solar system. And I can tell you confidently that this solar system, first of all, we tested it for the first 10 minutes, it worked. We continued for 15 minutes, it worked. Next 1 hour, the solar was still running. So you see that we ran the solar that day for about 3 hours without isolating any building in the facility. Initially, all the while, anytime we want to power the solar, we turn off that building where we have the damaged distribution board. We turn off about 5 AC units and 1 water heater. So altogether, about 8 AC units were turned off, a water heater, and a small building were turned off. Most times when we were testing for long with the inverter. But in this case, when we corrected the distribution board, the wiring in the ceiling, and the wiring at the back of the building that supplies the other smaller buildings, we now discovered that the solar ran without any problem and the parallel system stopped. The F41 error stopped occurring. We have not experienced it again since the last time we experienced it. I believe that's around the 1st of June. So you see that basically 2 reasons or 2 areas are the cause for a parallel system shutdown. First of all, it is how you connect your system on the inverter side. And secondly, it's whether you are having a short circuit or faulty equipment on the load side of your system. So for those who have been having issues with this F41 error parallel system stuff, I believe that this video will help you go a long way to troubleshoot your own system, because I believe everybody's system is unique and we may have created for ourselves or encountered different problems that could lead to this parallel system short. But with this information, I've given you about 4 specific reasons or 4 detailed areas that could lead to a parallel system short. I'm sure that one of the problems with your own system will fall in one of these 4 issues that I've actually described in this video. I wish you success in correcting your parallel system stop. And if you understand basically that the principle is uniformity, if you understand that there should be uniformity in your system, you can actually solve the side of your solar system problem. So when it comes to the load side, you then need to carry out some more rigorous troubleshooting and fault identification on your system. So basically, that's how you can actually solve the parallel system stop error. And I don't think F41 will ever occur again after you have isolated these things. But then, even if it occurs, you already know what could lead to it. So if you have a disconnected cable on your inverter side, it can lead to it. Basically, that's it. The inverter side could be a disconnected cable or poor wiring of the parallel connection. The load side could be a short circuit or faulty equipment. Basically, those are ways in which you can actually solve the parallel system stop on this brand of inverters. You can also consider this if you are connecting other types of inverters as a possible reason why your inverters are shutting down. Thank you for watching this video. This is Catchment of Resources, where we create for better living. Remember to like this video and subscribe to the channel in order to push this content to others who actually need it to solve their solar power problems. Thank you for watching this video.